Apologies, guys. I messed up the recording. So like we're in the middle of a question here, but I'll kind of reiterate. So this is homework 10, question number 8. And I was just saying that it's a pretty tricky one. And the only way I can like currently think to solve it is solving for part B or part 2, then doing part 1. So essentially we have a proton with a given energy, and then part 1, we're asked to find the speed difference between that and the speed of light, and then the momentum in part B. So here, this is our expression of total energy, which was given in the question in terms of momentum. So yeah, obviously we have the P on the right side. So we're just going to isolate P to one side, and then you should be able to plug in here and solve. So the reason why you need to do this first is because when you later express momentum at relativistic speeds, you actually have an expression by which you can isolate velocity, right? Because remember, there's a relationship between P and mv. So then in part A, we can find V through the following expression. So part A, make sure, still in camera here. Oh yeah, I can go all the way to the edge there. We can say V equals the square root of P divided by M squared. So, you know, like we're basically isolating V to one side. So we do that by dividing, like right here, divide by M. So essentially we're just, you know, swapping in that P over M for V, right? And because we have V on that side. And then we divide this, we divide that whole thing by 1 plus, again, P divided by M squared divided by C squared. So then this equation itself should look kind of familiar with the caveat that, you know, instead of V, we're going to have P divided by M on that side. And then that's how we should be able to find velocity. And then I don't think that, yeah, we're not asked for velocity. You just want to find the difference between that and the speed of light. So you'll just have to do some subtraction, where V will probably come out to be some very, like a number super close to 1, right? It'd be like, this is, I don't even know, but it'd be like V equals 0.999999, and then some number times C. So that's what I would expect. Okay. Yeah, I'm just going to pause the recording there and let me see if I can think of another way. I think I just thought of one actually. All right, 15 minutes have passed. The other way is way worse. Yeah, I would say proceed with this one. Moral of the story is solve for part B before part A. You can solve for B because you know P equals mv, and then E equals mc squared. So you can have an expression of total energy, which is actually what's given in terms of momentum as provided right here. And then secondly, you can use an expression to find V, right, where essentially you're just substituting P divided by M into that equation where V would normally be. So yeah, so part B, then part A, and that should bring you to some good looking answers. I would say, like, even if your answer comes out pretty different than the answer key, that's okay, just especially in part A, because the rounding is going to make such a huge difference, right? But part B, yeah, part B should be close to the answer key, because everything else should be rounded like within appropriate estimates, or at least should be as accurate as we're provided, which will match the answer probably. All right, so that's number 10, part B. Oh, and I guess like a little thing I'm going to throw in here. Look at number 5 on the worksheet 11 recording if you want to see how to do number 6 of the homework.